Support for Live in 225 is provided in part by the Grimm Family Center for Organic Production and Research at Cal Poly. For more information or to support the center, please visit organic.calpoly.edu. That's organic.calpoly.edu for the Grimm Family Center for Organic Production and Research at Cal Poly. Support for Live in 225 is provided in part by AgCom Central. Visit AgCom Central on twitch.tv/AgCom Central or on our website, agcomcentral.com, where you can follow our social media. That's twitch.tv/AGCOMM Central for AgCom Central. Support for Live in 225 is provided in part by the Department of Agricultural Education and Communication at Cal Poly. Visit aged.calpoly.edu to register for our programs or to show your support. That's aged.calpoly.edu for the Department of Agricultural Education and Communication at Cal Poly.
Good morning, everyone, and welcome to Season 1, Episode 9 of our Organic Agriculture podcast series, Live in 225. I am your host, Natalie Victorine, and with me we have a lovely set of panelists today. We have...
I'm Morgan. I'm a second-year AgCom student, and I'm the student panelist.
Dr. Matt Grishop. I'm the director of the Grimm Family Center for Organic Production and Research.
And I am Moses Mike. I'm an AgComs professor and trying to keep things glued together.
You're doing a great job.
Yep.
And with us on Zoom, we have some really special guests. We have Eric Morgan. Hello.
Hello, my name is Eric Morgan. I'm the Vice President, Environmental Science and Resources at Braga Fresh. I also have a soils lab called Soils Health Lab, LLC.
Nice. Lovely to have you today. And then we have Gina Bella Colfer. Good morning.
Hi, thanks for having me. Excited to be here. I work with Wilbur-Ellis as their sustainability agronomist on the West Coast.
Nice. So basically, today's podcast episode, we're going to be comparing and contrasting some of the major farming practices that are used in conventional agriculture versus organic agriculture. So this will be a really fun episode to dive into because the consumer public is not particularly aware of some of the differences between conventional and organic. For instance, does organic production use pesticides, fertilizers, etc., and what is the difference between what they use to conventional farming practices? Again, there are a lot of misconceptions about how organic ag differs from traditional agriculture, so the purpose of today's podcast episode is to directly compare them to try to clear up some of these misconceptions and educate the public about the food that we grow, especially organic agriculture. I just wanted to get right into it and start the discussion off with fertilizer and the use of fertilizer in the organic industry. I wanted to first start the discussion with clearing up the difference between synthetic and non-synthetic fertilizer and how they work a little bit differently. So, Dr. Grishop, if you wanted to start off the conversation about what is the difference between synthetic and non-synthetic fertilizer?
Well, I can talk a little bit towards that, but I think our two panelists can really have a home run with that. So my 2 cents are synthetic fertilizers are either produced from fossil fuels. So most of the nitrogen that we use in agriculture is from a process called the Haber-Bosch process, which uses a lot of natural gas to fix atmospheric nitrogen into a form that plants can access. Other fertilizers are mined and come about in different ways, things like potassium, phosphorus, etc. In organics, we use essentially organic waste products that are processed in one way or another to be used as fertilizers. So by organic waste products, I mean things like old plant material, animal rendering byproducts, manure, things like that. But I'm going to turn it over to our panelists.
Yeah, you hit it on the head there, Matt, with that the synthetics are derived from petroleum byproducts, the Haber-Bosch natural gas process, where the fertilizers come from a myriad of different upcycled, I would say, waste products. So be it chicken litter, compost, we have pelleted fertilizers that use chicken litters as the base and then use animal proteins like meat and bone meal or feather meal, and then also there's seabird guano to raise the nitrogen content of those pellets, because nitrogen is definitely a limiting factor when you're farming intensive vegetable operations. So you want to be able to get that nitrogen in the ground. The way that the plants are able to obtain that nitrogen is the animal waste product goes through a mineralization process in the soil, and then it converts it into ammonia that then goes through to nitrite and then into nitrate, which the plant takes up readily. So it goes from an organic nitrogen to the inorganic nitrogen form in the soil that then the plant can take up readily. And nitrate is nitrate, be it comes from a synthetic form or an organic form. The plant takes up the NO3 molecule the same in the soil. But it's the microbial biomass that converts that in the soil. And then there are liquid products that can be applied that are organically derived from fish meal or soybean protein hydrolysates. So there's a lot of different naturally derived organic fertilizer materials that can be applied to the crops and then converted in the soil by the mineralization process.
I was just going to add, so just to be upfront with some of the challenges that we have with organic fertilizers, when we start talking about animal-based manures, generally the composition of those fertilizers is higher in phosphate than what our crops need. So we have to be careful even with organic fertilizers. Using organic fertilizer does not mean that you're eliminating any kind of environmental risk or potentially human health risk. And so we do need to take caution with those products as well. You can over-apply those products and cause environmental issues, but it's a little harder to do because of the slower process of the natural materials. It's...
I had a quick question, just out of my own curiosity. Since you're using like animal waste products, do you have to heat treat
that's a really good
fertilizer for it to become not sterile but acceptable to put onto products that are used for human consumption?
I can talk to that.
Yeah.
So I'll try not to steal too much time. So we get all of our fertilizers from True Organic Fertilizer.
Oh.
We have the food safety thing really, really dialed in. And so every batch of fertilizer we get is tested for all the human health pathogens. Heat treatment is their primary way of, removing those. But there's a whole entire paper trail in testing, and really that paper trail goes from the start of the fertilizer formulation all the way until we're tracking everything until it hits our retail partners' shelves. So there's traceability back all the way through the entire process. But even in organic agriculture, food safety is really the number one priority.
Definitely. That's really funny that you mentioned that. One of our first podcast episodes, we had one of our students' dads, who is kind of the CEO of True Organics. That's really interesting that you mentioned that. I kind of wanted to speak on this little saying that non-synthetic fertilizers feed the soil and synthetic fertilizers feed the plant. How true is that statement when we're thinking about fertilizer from a sustainability standpoint?
I'll start, and then Eric can clear up anything that that I say. So when you have a synthetic fertilizer, it's in the available form for the plant to uptake. So you don't really need to go through the mineralization process within the soil. What happens with the organic fertilizer is, for the most organic fertilizers must go through the mineralization process within the soil. So the healthier your soil, or the more microbial biomass you have within your soil, the more efficient that mineralization process is going to occur. And then also it has to do with the carbon to nitrogen ratio. So the lower your carbon to nitrogen ratio within those organic fertilizers that you're applying, the faster that mineralization process can happen. So say a soy protein hydrolysate has a very low CN ratio of 3:1. So that process happens very fast. Those are amino acids. They do not really require a microbial breakdown in the soil. They're a faster acting, more shot in the arm to the plant. Whereas the dry chicken-based type of fertilizers do require a mineralization process to go through. There are new technologies that are happening within the organic industry where they're producing ammonium nitrate liquid products from a biological process that's happening at the chicken house facilities and dairies, where they're capturing the ammonia that's being released from the compost piles or the waste streams, the dairy effluents. And so they're capturing that ammonia and then adding a microbial product to inoculate that and creating an ammonia nitrate product. But this is through a biological activity of capturing the ammonia that would have been released to the atmosphere. So it's kind of a closed loop cycle, but this is a more, it's an ammonia nitrate product. So it is something that doesn't need mineralization within the soil profile to happen. It is already readily available to the plant. And then, we're trying to head toward working with more residue in the soil. And, if we're going to move toward the regenerative movement, we're going to have to figure out how to work with the residue in the soil, which, when you have a high carbon and nitrogen residue, that carbon ties up the nitrogen that otherwise would be mineralized. So it's being tied up by those microbes that are feeding on the residue, that high carbon residue. So then it's pulling nitrogen away from the plant. So if you're able to spoon feed an available nitrogen, you're feeding the microbes to help them speed up the breakdown of that residue. So there's different techniques that can be used to help feed the microbes, to keep breaking down the organic matter that's in that soil and then keeping that nutrient cycling going.
I mean, I wanted to chime in here and I wonder if the mineralization process has any effect on the quality of the output of the plant. Okay, so you're doing the difference between synthetic and non-synthetic fertilizers, from what I've gathered from what you were saying. And I'm not an organic specialist. I'm an ag communicator, so I'm trying to understand the communication side of things. Is that, synthetic fertilizers, this stim shot, this drug, I'm not sure if I'm able to say like cocaine on this podcast, but I'm going to say it anyway. So you're giving this plant some crack. Stimulant drug to the plant for it to perform at its quote unquote optimal level. However, non-synthetic fertilizers has this additional step of mineralization. Is there any evidence, research or otherwise, that the quality of the outputs of these plants are different? And if so, is there any description of the differences?
Are you talking like nutrient density type?
From nutrient density all the way to taste and smell.
There is an organization that is working on that now to determine nutrient density and post-harvest quality, but the jury's still out on that, really. But you have to look at, it's not, to me, it's not so much that, but rather the pollutant quality of the synthetic fertilizers. And we've over-applied them because they've been inexpensive in the past. I mean, now cost is definitely an issue because, everything's gone up, but nitrogen costs, phosphorus costs, they've all skyrocketed. So now everybody's really looking at their input costs and are trying to scale back. But in the past, we've just, more is better because we've relied on these synthetic chemistries to do all of our heavy lifting without really looking at what our soil microbial diversity can do for us in the soil. So we've over-applied, we've caused, nitrate levels in our groundwater to explode. We've caused, phosphorus in our runoff to cause algal bloom and create other issues. So it really is the environmental effect from these synthetic chemistries that have been the big detriment for farming in my book.
And I know Matt has a lot to say here. I was just considering, and I hear you on the rationale between synthetic, non-synthetic. I was just wondering how can we how can we get this information to the consumer in a way that they would want to consume it? Because not all consumers are going to be concerned with the environment, the environmental aspect because of cognitive distance, psychological distance, because that's a phenomenon where, okay, as a consumer, I'm not really close to the soil, I don't have a farm, I don't have land, as most consumers may not have. I'm speculating here. And so that psychological distance means that they're not super concerned with the environment. But then there are the consumers that are really concerned about the environment and can afford to purchase and consume organic products. So I'll let Matt go from here.
Well, so I think what Gina said was great. A way to maybe simplify that a little bit is it's really about mobility of the nutrient and the plant's ability to take that nutrient up. So the pharmaceutical example, whether legal or illegal, is not a bad one, or it's not a bad metaphor. I mean, so what it comes down to is a plant's root system can only take up so much nitrate or ammonium or nitrite, more rarely, at one time. There's only so much capacity. Just like if we eat a lot, there's only so much capacity to digest food rapidly. And so over time, it's going to sit with you or flow through you. Same thing with the plant. So what we do when we use synthetic nitrogen inputs, and I'll just stick with that because it's easy, we put things out in a very available form. Well, one of the characteristics of that available form is it's highly mobile. If the plant can't use it, it's going to go down into the water because it moves readily through the soil profile. It dissolves in water very easily, which is one of the things that makes it great as a fertilizer, right? Where it goes up into the atmosphere is nitrous oxide or elemental nitrogen. With an organic fertilizer, everything's locked up in these more complicated systems, these big molecules. And so they're not as mobile. They don't go down through the soil profile. They don't go up into the atmosphere very readily. And we rely on those microbes to slowly make them available to the plant. So the spoon feeding analogy, I think, is a really good one. In a natural plant system, the decaying wastes of previous plants, the leaves, the fruit, the animals, whatever else was there, is what provided, the current nutrition. And that's a really gradual, slow process mediated by these complex microbial relationships, which are incredibly diverse. So what it comes down to is like the quick availability. Nitrates are like fast food. You get it right away. It dumps a bunch of nutrients into you. It's very simple because there's not a lot of other elements in those molecules. It's not a big amino acid with a bunch of random trace elements and all kinds of stuff in it. It just has the big three: nitrogen, phosphorus, potassium. And the plant can either take it up right away or it can't. If it can, it goes somewhere. And so that's the environmental side. Some really interesting research that was done on the pest management and entomological side on this was done at Ohio State in the late 90s and early 2000s by an entomologist named Larry Phelan. And he did some really interesting work looking at corn earworm, which is an interesting pest because it not only attacks corn, it's the worm in the ear of your sweet corn. It also attacks tomatoes. It actually attacks cotton and a whole bunch of things. It's a really interesting critter. But what he did was he looked at the chemistry of leaves being grown under a really heavily compost-based organic soil medium and a traditional greenhouse medium where everything was delivered in these available nitrates. And what he found was that the corn earworm preferred to oviposit or lay its eggs on the conventional plants. And he was able to track that back to the fact that the hypothesis is that there's a bottleneck happening with these plants where plants go through photosynthesis, right? That's how they make sugars. And then there are those primary photosynthates basically are processed into proteins and things, right? So the plant can build its own cell walls, its fruit and everything. And then we can enjoy those as consumers of plants and things that consume plants. So, but what can happen is if you overload the plant with these available nutrients, it bottlenecks. Basically, the early stages of biosynthesis of all these compounds that the plant needs to produce are way overexpressed, and the later things, which are things that actually help the plant have an immune system against insects and other creatures, is downregulated. So, and the insects can sense this. I mean, they can taste it basically. And so, what he was able to show is that you had the pests preferring these plants that had a high quantity of these early, easy to digest nitrogenous compounds, and plants that had a more sort of diversified profile of compounds were not as preferred as much. And that's been played out with aphids and a few other pest species. And so, the human nutrition side is really complicated. I mean, you get into, what were the conditions it was grown under? How ripe was it when it was picked? What variety was it? And then how long did it take to get to the consumer? All of those things are going to affect the nutrition of the food by the time it gets to them, especially in things like fresh produce. Grain, not so much. But I like to think about it as, I love the spoon feeding. In an organic nutrition program, the soil, you have a living element to the soil. The microbes are spoon feeding nutrients to the plants, slowly and surely, at a rate that the plant is sort of evolved to take up over the hundreds of millions of years that we've had plants. In a conventional nutrient management program, it really is. It's like, nope, we're just going to give it a big old shot of available stuff, and it's going to have everything it needs to go really, really fast. But guess what? Plants didn't evolve that way. We've bred them to respond to that type of fertility, but their basal sort of evolutionary experience was with, I'm feeding on the organic wastes of yesterday. That's it. Life comes out of death. Death feeds life.
And the symbiotic relationships that take place in the soil as well. So
absolutely,
that cycling, and really what I think you're talking about is the difference between a healthy soil and a healthy plant. And I think that we need to start looking at what the relationships are, because healthy soil is such a buzzword, but I think what we're missing is healthy plants.
Yes.
Plants that can, and that's what our work, what we're doing on the regenerative side. Can we, have climate resistance? Can we farm with less water? Can we develop resistance to insects and diseases? And so that's really where our focus on is at right now, is really trying to figure out what a healthy plant is and how do we get it there. And so much of this, both we see the same challenges on the conventional and the organic side, but really for the long-term viability of providing produce to the world, we need to be able to do a better job of providing a healthier plant that evolved, as you said. I think about evolution all the time, and the plants that were weak in nature were taken out by insects and pests. And so we don't allow that to happen with our inputs. And so sometimes we don't have the strongest plants. So let's work on healthy soils and healthy plants, and the symbiosis there, and the symbiosis with our bacteria and fungi in the soil. There's a lot. We're having a lot of fun looking at all these things right now.
Fantastic.
Definitely.
Yeah, and I think the crux of that, in the building the healthy soil, building the healthy plant, is getting and keeping organic matter in the soil. Absolutely. Because that is the food source of the microbial biomass. And the more diverse the organic matter, be it from organic fertilizers, which have high carbon, a ton of 442 has 300 pound, or 1,000 pounds of 442 has 300 pounds of carbon. Cover crop, when you incorporate it back into the soil, can have up to 4,000 pounds of carbon. So you've got to get carbon into the soil, you've got to keep and manage that carbon, and then fertilize to what your plant needs and what those microbes need to keep that cycling going.
And some of it's counterintuitive too. The way that we measure soil health, one of the metrics for soil health measurement is CO2 respiration of the soil. So much of the focus is on CO2, being bad and causing climate change and everything else like that. But at the same time, the way that we analyze a healthy soil is to see how much CO2 it's respiring. The more CO2 that you're respiring, the bigger, the healthier the soil is. And so trying to kind of to figure that out, it gets a little bit in the weeds really quickly, but that's one of the things that we're working on. Dr. Grishup's a bit aware of this, but we're actually monitoring real-time CO2 respiration from our soils in the hope that they can build an algorithm to use it to quantify soil carbon sequestration. So I'll say that hopefully not all of the carbon is being respired, but that is part of the natural process. If you apply compost in a Mediterranean climate, it is largely turning to CO2 at some point with standard tillage practices and standard production practices. So that's kind of where we're going next. And I know Dr. Grishup's interested in that, and I know Gina is as well. Is how do we figure out and keep that carbon in the soil at the same time, knowing that the more we do, the more CO2 we're going to be respiring from the soil. But plants like higher levels of CO2. And so hopefully that's something, that we can figure out. They'd be happier with more CO2 than we have in the atmosphere right now. So hopefully as these healthy soils respire more CO2, the plants take that in as part of their photosynthetic process. So,
yeah. And if you have a communication aspect of that project, please let me know. I'd love to partner with you if that's a possibility.
Oh, we can make that happen.
Yeah. Speaking of communications projects, I wanted to hand it over to Morgan, who is our production specialist for this episode, to talk about a video that her production group made for this episode. If you wanted to talk a little bit about that.
So we made a pretty quick video where we went out to the Cal Poly campus and we filmed man-on-the-street interviews. So we basically went around and asked people what they knew about the difference between organic and conventional agriculture. And we got a lot of people, some people with an ag background, some people they knew nothing about ag, which was great. So we got both sides of it. So it'll be interesting. You'll see what people have to say.
So the question is, what are some of the key differences between organic agriculture and traditional agriculture?
I don't know a ton. I know for organic agriculture, they don't use the same pesticides and treatments.
I assume that organic is a little healthier. And yeah, that's about it. I don't know.
All right, so organic agriculture does not use industrial pesticides or additives. It's really just the natural process of fertilizer with organic inputs so that there's no artificial amendments to the soil or the process of that.
I truly don't have any idea. I feel like organic would involve a little bit more GMOs, maybe?
The only thing organic really means is it's not made out of rocks. Organic agriculture, less intense pesticides more often. Plants are more affected by pests.
You have to pass like certifications to meet the organic standards, which I'm pretty sure is like not using any chemicals.
Organic agriculture involves the use of natural substances as opposed to chemical fertilizers.
I think organic just means not using pesticides.
I would say that traditional agriculture uses methods and practices that are not in some way certified or labeled organic in some sort of way.
They have to use a certain type of fertilizer as well. Yeah, that's about it.
I would assume that organic agriculture keeps the planet and the environment in mind more, but I really don't know that much about it.
Yeah, it's chemicals you put in it.
Chemicals?
Yep, yeah, what you can use to fertilize. Yep.
Organic, I'm guessing it's just going to be like stuff made in a lab or something like that, or I don't know.
Well, I would say definitely the pesticides used. I know that the land has to sit and be pesticide and like GMO free for 5 years or something like that.
The soil used, that is what I know. And also, I think it has to do maybe with the types of crops grown.
Organic agriculture is just where you make organic things, and then traditional is like very like, I guess like, I don't want to say processed, but like chemicals, I guess.
For consumers, we use GMOs to make like apples bigger or them to last longer or to look better. Is basically the difference. And with organic, you kind of just have to go with what their genetics made them to do.
They don't use pesticides and stuff in organic agriculture.
Maybe say like organic is like studying like maybe more of the soil science with it. Traditional is maybe just the way things have been done traditionally for a while.
So, like Morgan explained, they went around and asked a bunch of people just what's the difference between organic and conventionally grown commodities, and they really got a wide range of answers. Morgan, tell us about some of the answers that you got and what may have surprised you or not.
So we did get a couple of people who are from the College of Agriculture, and they knew a little bit about the differences. And then we got some people that have no idea what organic even is. And it was interesting because some people knew organic from the labels on the grocery store, so they automatically said, oh, organic has no pesticides. That was like the really general assumption for all the people who didn't really have any clue. There were some answers that were really out there that people really had no idea. Like the guy that said organic was more GMOs.
Which is absolutely the opposite of the case for organic agriculture.
Yeah, and then there was the people who had a lot of background knowledge and they started throwing out terms. I was like, they know what they're talking about. So it was fun to see like such a range of knowledge in such a small like population of people.
I thought it was interesting. One of the responses that really stood out to me was the person who talked about how organics keeps the well-being of the planet in mind, and I think that was a really good point because we were just talking about how the use of non-synthetic fertilizers really keeps long-term production in mind, and really just caring for the soil and the microbes in the soil for the plants in the production. And I thought that was just really interesting that the first thing that she thought about was keeping the well-being of the planet in mind in terms of organic versus conventional. Something else that really stood out to me, like Morgan was talking about, was the public's perception of the fact that organic production does not use any pesticides, which kind of leads us into our next point for the podcast today, which is just talking about the difference between pesticides in organic and conventional production. What are the misconceptions? What's the reality? And I thought that was just a great way to start the discussion about it. So one of the biggest misconceptions is that organics don't use any pesticides, which is not true. Organic farming actually does use pesticides, but it's a naturally derived pesticide. If Dr. Grisham, if you wanted to talk about that a little bit, or if any one of the panelists wanted to tackle that as well on Zoom.
I want to tackle it.
Oh, okay, Dr. Mike, tackle it.
Because I had a lot of fun going up to Braga. And we actually got to see what Dr. Grisham was talking about in class, where we identified some ladybugs that were in the field helping or assisting the field manage their pesticides. So that's like a natural pesticide, an insect related. What's the correct term for it?
Biological control.
Biological control. Communications. And so that was really interesting, and it was more fun for me when the students recognized that, we're not just blowing hot air when we're standing in front of a classroom talking about these things. They're actually seeing the ladybug larvae, the ladybugs, and all the biological controls happening in the field at Braga Fresh. So that was impressive for me.
Yeah. So on the pesticide front, what was said was largely true. There's an approved list of largely naturally derived compounds that can be used for organic production. There are one or two synthetics involved, but they're really kind of fringy and weird. They basically don't actually kill things. There's some mating disruption products that are allowed, and these are pheromones. Basically, for insects, one of the big problems is you're this little tiny critter in this giant world. How do you find a mate? Especially if you're not really dense in the environment, if you have to travel long distances. And so one of the major ways that many insects use to accomplish that is the female has a special perfume that's a very rare signal in the environment. These are very species specific things, and it's a rare signal that males can use to track her down, and that's all. In most critters that do this, that's all the male's there for. It's about making babies, and that's it. 4 days and you're done. So it's like the reason to live for the marriage. Yeah, exactly. So what we can do is, if we identify what those pheromones are, we can synthesize those compounds and put them out in mass in a field. And so that basically shuts down the system. It makes it so that it's really hard for the male to find the female because the signal's no good anymore. It's like trying to watch your favorite TV show when there's a lot of static. You can't make out the people anymore on your TV show. So that's the only synthetic I can think of. But largely, the big thing about these natural pesticides is that, especially the more biological ones, things that are actually living organisms like viruses or bacilli or fungi, they tend to be much more specific in their activity. So, a good conventional neurotoxic insecticide kills all insects. There's been a lot of talk about these pesticides killing bees. And it's like, well, bees are insects. Yeah, it kills them. That's what it does. That's what the chemical engineer who designed that's what they designed it for. A lot of the biologicals tend to be much more specific. So, for instance, BTs, or Bacillus thuringiensis, really different strains of this bacterium only affect different types of insects. So the ones we use most in vegetable production kill caterpillars, and that's it. They don't have an impact on aphids. They don't have an impact on ladybugs. They don't have an impact on parasitoids that attack caterpillars or aphids. All they kill are caterpillars, and really just certain types of caterpillars even. So that most of our organic pesticides, the ones that I typically suggest people use, are very specific, whereas our conventionals tend to be very general. It's nerve gas, man. You put it out there and it's going to whack anything with 6 or 8 legs.
I have a quick question, just because I know that you have to get pesticides used for organic production regulated and approved by the USDA. And I have a list from Global Organics, which is like a news site that we did some research on, and it says that there's about 25 approved organic pesticides compared to about 900 approved conventional pesticides. And you were talking about the very species-specific pesticides that are used in organic production compared to the blanket of conventional pesticide. From a production standpoint, would organic producers use more pesticides that are non-synthetic because they're so species specific?
It's very context dependent. So ideally, and in our Central Coast vegetable production, really pesticides should always be viewed as a last resort. really you should be building biocontrol services into your system if you can. If you want to have long-term success, that is the pathway to success, because the products that we have available for sort of emergency applications they're very specific, they're very costly, and they tend not to last very long, and they tend not to be they're not nerve gases. They're not as good at killing things. So really, I think Gina and Eric can speak to this probably much better than I can. But ideally, you're starting with building a system where you have the good bugs, the good guys, the predators and parasitoids there all the time. So they're there to build up and manage your pests for you. And I'm going to let Gina and Eric take it.
I'll jump in here just real quick. So my background was early on in my career was primarily conventional. So I have a lot of experience in both systems. And I just need to say that there's definitely a distinction, but I don't know how much of a distinction there's going to be in about 10 to 20 years. Yeah. The conventional chemistries that we're utilizing, the classes of chemistries that are showing up where we don't want them. So these chemicals were registered and primarily tested for certain environmental concerns and human health concerns, and they look at the LD50 and how lethal the product is. But with the classes of chemistries, primarily pyrethroids, neonicotinoids, carbamates, and organophosphates, in California, I don't anticipate those being viable options for any grower in about 10 years or so. Yeah. And those classes of chemistries will probably make up 75% of the products that we're using. And so growers need to find a way to look at the future and see what's coming. Pyrethroids and neonicotinoids are showing up in waterways, causing the little invertebrates and stuff, or whatever the little critters they have, to die. Leading up the food chain. We're seeing things, neonicotinoids and pollinators. We have protected pollinators now in the state of California as an endangered species, and really the regulations are coming that are going to affect those. And so those chemical inputs in my tenure have been letting me down. We still do some conventional farming. About 20% of our conventional farmland is still conventional, and we have issues that we have absolutely no control over with the typical industrial conventional chemistry. The diamondback moth, which Dr. Grisham mentioned earlier, we have resistance to it with all the traditional conventional chemistries. It doesn't work. What we're relying on primarily now is an organic chemistry, the Bacillus thuringiensis. And so it's not looking too good. We have a huge problem with INSV. We used to have no problem with vector, the Western flower thrip, and now we have a hard time killing the Western flower thrip with the conventional chemistries that we've been utilizing for them. And I would imagine with these chemistries, we're going to continue to see increased levels of resistance across different populations, and the environmental concerns that seem to keep on poking their head up. It just in California is not afraid of putting the environment first. And so conventional growers need to be aware that tools are going to be limited, and even from a future standpoint, I don't see that there's going to be a whole lot of new chemistries that are being able to be introduced into California and eventually the rest of the United States, because there is some type of, there's always going to be some little legacy. And that's why you're also, in my opinion, seeing the larger chemical manufacturers start to acquire biological companies. These acquisitions seem to occur every 6 months or so, where a large, multi-billion-dollar company buys a smaller company that specializes in biologicals. So this is the direction it's going, and we really need to figure it out to lay the groundwork for how we're going to continue to provide, a healthy, reliable food source for the world, and at the same time mitigate the environmental and human health concerns that some aspects of conventional farming do present. I would say that the food supply is very, 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 very safe on the conventional side, but we've been a little rough on the environment, and we're starting to see that just even in insect populations with resistance. So,
what can we as agricultural communicators do to help the cause? We've asked this a number of times in a number of different ways, but from where you sit, what role does agricultural communications play in this sort of futuristic outlook for organic agricultural production?
For speaking for our company alone, I hope Gina agrees with me, but trying it a different way and being successful with it. So really, looking at kind of the pure tenets of capitalism. Can we achieve a new goal? And then once we do, if we're able to demonstrate it, demonstrate how changes to the system that we're a bit of the tip of the spear on the progressive side with the regenerative stuff. And if we're able to be largely successful in that and take market share, the rest of the industry is going to have to come with us. Growers like to see what people are doing that is successful and then copy it. And so that's kind of our hope, is that, we're failing left and right with the different things that we're trying, but we're having some successes too, and the successes are fun, and the failures are getting to be a little bit less and less. So really, to me, there needs to be a shift on the production side, and I think that innovative growers and people taking chances and communicating in opportunities like we have today about the challenges that we face and the different directions that are available to us. We can't stand pat where we are and pretend that things are not going to change. They're changing every day. What are we going to do to adapt to them? So my hope is that market forces alone will be enough. The regulatory hammer is a big motivator for me, but really I think the way to facilitate change throughout the entire food production system is to lead by example and to be successful doing it and try to shift the market.
I was just thinking about the lead by example definition. I think that's a great way just to facilitate this change, because you're right, the agriculture industry is changing every day, and the current system that we have, a lot of people say that conventional farming is definitely systemized, and we have to understand that there's going to be change. There's changes happening every day, and in order to meet that change and meet the changing inputs like land, like you were talking about, preserving the land with organics, and really just talking about the welfare of our environment, we're going to need to make some changes. And I think that leading by example is definitely a great way to start.
Well, and it sounds to me like on the ag comm side, what I think I heard was getting involved in telling that story. So making sure that we're amplifying that message that, hey, we're facing challenges, but we are seeing some successes in how to deal with that, and here's where we've been successful.
Well, I just want to throw my 2 cents worth in on the, synthetic versus the organic pest management side of things. And so I'm like Eric, I've walked both. I've done the conventional side and I've done the organic. And, most recently, last 15 or so years, pretty much just organic, but still, see what's going on with the conventional. But I've been able to walk different organic ground where you have the higher fertility ground, where a grower has more biodiversity on the farm, where they have insectary habitat plantings, which are critical within a farming system to support the biologicals, the serpent flies, the minute pirate bugs, ladybird beetles, lacewing. So important versus the organic grower that maybe is farming on less fertile soil. So then your plant maybe isn't as primed and has that natural defense mechanism from a crop that is on the higher organic matter soil. So that is primed. I mean, that's where a big difference between a healthy soil versus soil that's just a lower CEC. It's it's no fault of the grower, it's just the ground that they're farming on. So then there's different pest management strategies that have to come into play, whereas if you're on soils that are really fertile and you have this habitat built in, you could probably get away with maybe just a BT spray because you've had a diamond brack outbreak. But a lot of the aphids are controlled by these predatory insects that come in, and the parasitic wasps that come in that are supported by the insectary habitat plantings. Whereas if you've got a crop that isn't supported by this really high organic matter soil, and they're a little more stressed, they're not as resilient, they might not have that defense mechanism built into them to fight off that high population of insects, say aphid, that come in. And then if they don't have insectary plantings, then they are more kind of tuned into, okay, we need to come in and spray. And so what products are offered for organic growers are things like natural pyrethrins that are really short-lived and aren't as efficacious as your normal pyrethroid on the conventional side. And then there's a product called Entrust that used to be effective on thrip and lepidopterans, but now through our overuse, we've built up resistance to this product. So our reliance on these products aren't as they're just not as guaranteed as, say, they were 10 years ago, where if we did have an emergency, we could come in and put a pyrethrin on. That's a very short-lived product and knock back the aphid. So now we really need to rely on these beneficial insects, keeping the insectary habitat in place to support these insects, and then also, like Eric was saying, the biologicals, because we are going to have pathogens. We're going to have downy mildew outbreaks. We're going to have different issues. Anthracnose is going to be an issue coming up. So we need to always be testing and looking out for new biologicals to use as inoculants within the system, because maybe those bios, like a trichoderma or a streptomyces or a Beauveria bassiana, isn't in the system. But if we could inoculate the system with those different biologicals, can we help prime the plant to help its defense mechanism against these pathogens later in the season? So there's just different, techniques that are used also.
We gotta stop. I'm so sorry. We're in a classroom, so we have to wrap up right now. I'm so sorry. We do enjoy.
This is a really great discussion.
But I'll let Natalie take it over.
Yeah,
here.
I'm sorry that we have to cut things short. I really thought that this discussion was insightful. It's definitely left me with a lot of ideas on how to share the story and how to really facilitate that progressive change for the agriculture industry. I just want to say thank you again, Gina and Eric, for joining us today on the podcast and providing all of your insight and input with your respective industries. It's really just been super informative. Morgan, Dr. Grisham, Dr. Mike, again, thank you for sitting on the podcast. And this has been our time in Live in 225. Thank you again.
Thank you so much for joining us.
Thanks.
Live in 225 is a production of the AGC 225 class at Cal Poly called Digital Communications in Agriculture. Program funding was provided by the California Certified Organic Farmers Foundation and the Transition to Organic Partnership Program. Our production team for this episode was Morgan Elia, Lauren McEwen, and Griffin Wilson. Our director for Season 1 was Bella Anushian. Our host was Natalie Victorine. The executive producer, creator, and co-editor for the show was Moses Mike. Matt Griesop was our co-producer. Our student panelist was Morgan Elia. Our guests for this episode was Eric Morgan of Braga Fresh and Gina Bella Colfer of Wilbur-Ellis. Our audio technician was Melissa Frago, who was also our managing editor. The video switching director was Griffin Wilson. Our vocal talent was Jared Mandrell. Background music by LVY Music from Pixabay. Intro and outro music by Alex Grohl from Pixabay. Thanks for joining us.